Hello students, so in this video we will be covering a few more questions from the topic ellipse. So before watching this video, I recommend you to kindly watch part 1 ellipse. The question says let the ellipse E x square by 144 plus y square by 169 is equals to 1 and the hyperbola x square by 16 minus y square by lambda square is equals to minus 1 have the same foci, okay? If E and L respectively denote the eccentricity and the length of lattice rectum of H, then the value of 24 times E plus L. See, to find the eccentricity of hyperbola, we have to first find lambda, and even to find the length of lattice rectum, we have to find the value of lambda. So for that, I think we have one condition which is given. I think this is a procedure based question. He has given that they have the same foci. So the first ellipse, here b square is greater than a square. That means the foci will be of the form 0, plus or minus b, right? So let b1 e1 be equals to b2 e2. What do I mean? This is for ellipse and this is for hyperbola, okay? So we'll go one by one. What is b1 here? That is 13 as per this, right? And what is e1 equals to? That is under root of 1 minus a1 square divided by b1 square, because it is the eccentricity of ellipse, right? So we will get 1 minus 144 divided by 116, which is under root of 25 by 169, which is 5 by 13. Okay, now what is b2? From this equation, b2 is lambda, and what is e2? That is under root 1 plus a2 square by b2 square. So that should be 1 plus 16 divided by lambda square. So it should be under root lambda square divided by 16 plus 16 divided by lambda. So if I try to use this particular relation, what do I get? I get b1 which is 13 into e1 which is 5 by 13. So I can write 13 into, let me erase it, I can write it once again, 13 into 5 divided by 13 will be equals to b2 is lambda and e2 is this. So I can write here lambda into under root lambda square plus 16 divided by lambda. So we can cancel this. Of course, under root lambda square is mod lambda. If you want to write, you can write. But anyways, lambda should be positive for this to be right, conjugate hyperbola. Fine. So we can cancel this also. We get 5 is equal to under root lambda square plus 16. So 25 will be equals to lambda square plus 16, and lambda square will be indeed a 9. So therefore, lambda should be equals to 3. As I said, lambda should be positive for this to be a conjugate hyperbola. Now we need to find the eccentricity of hyperbola, that is e2. That should be under root lambda square, which is 9 plus 16 divided by 3. See, if lambda is negative, we'll get eccentricity as negative, which is not possible. So we get e2 as 5 by 3, and I think length of lattice rectum will be 2a square by b. So 2 into a square will be 16 divided by b is lambda, which is 3. So we get 32 divided by 3. So now what is he asking? He's asking us to find the value of 24 times e plus l. So 24 times e, that is 5 by 3 plus l, should be 32 by 3. So we get 24 into 37 divided by 3. I think this will be 37 into 8. I think the units digit should be 6. So what should be the answer? Okay, it could be 126 or 296 probably. So let us quickly find out. So it should be 296. 296 is the answer. So that's it. Option 4 is correct. Dear students, let us now go to the next question. Next question says let the length of the lattice rectum of an ellipse be 30. That means what is given here? Here a is greater than b. So 2b square divided by a should be equals to 30. That means b square divided by a, that should be equals to 15. Okay, this is given. And if the eccentricity is the maximum value of the function, okay, very simple, f of t, this is a quadratic equation. Either this is a downward facing parabola, so we can find the maximum value that will be at the vertex, or we can make use of derivatives. So for maximum and minima, we'll first find first derivative, that should be 2 minus 2t, and for maximum and minima this should be equals to 0, that means t equals to 1. And let us find the second derivative, f double dash of t is minus 2, which is less than 0, that means at t equals to 1 we get a maxima. So e is nothing but f of 1, which is minus 3 by 4 plus 2 minus 1, so which is 1 minus 3 by 4, which is 1 divided by 4. So the eccentricity is 1 divided by 4. He is asking us to find the value of a square plus b square. E square is 1 divided by 16, and 1 divided by 16 will be 1 minus b square divided by a square. So b square divided by a square will be equals to 1 minus 1 by 16, which is 15 divided by 16. Now we can write this as 1 by a into b square by a, which is equals to 15 divided by 16. And what is b square divided by a? B square divided by a, I think it is 15. So we can write 15 here. So basically a is equals to 16. Once a is equals to 16, can we find the value of b square? So from here b square will be equals to 15 into 16. So what is he asking? He's asking us to find the value of a square plus b square. So a square plus b square should be, I think b square is 15 into 16 and a square is 16 into 16. So we can write it as 16 into 16 plus 15 into 16. So definitely we can write it as 16 into 16 plus 16 into 16 minus 16, right? I hope you can write 15 into 16 as yes, this. So we have 2 into 16 square minus 16. So this should be 2 into 16 square is 256. So this should be 512 minus 16. So it should be less than 500. I think this should be the answer, just less than 500. So you can calculate 12 minus 6 is 6, 10 minus, yeah, it should be 9. It should be 496. That's it. So 496 is the correct answer. Let us now go to the next question, dear students. Next question says, let h comma k lie on a circle. Okay. See, whenever they say it lies on the circle, we can think of parametric coordinates. Let us see if it is useful. And the point lies on an ellipse with eccentricity E. Oh, wow. This is a good question and a very simple question. See, I will say any point on the circle will be of this format, 2 cos theta, comma 2 sin theta. So let me say h is nothing but 2 cos theta and k is nothing but 2 sin theta. Now, what is this point P? Point P has the coordinates as 2 into 2 cos theta plus 1, comma 3 into 2 sin theta plus 2. So basically we have the coordinates of P as 4 cos theta plus 1, comma 6 sin theta plus 2. Let me say this is x comma y. That means x is equals to 4 cos theta plus 1 and y is equals to 6 sin theta plus 2. So can I write x minus 1 by 4 is equals to cos theta and y minus 2 divided by 6 is equals to sin theta? Yes. Now we know that we have to eliminate theta, so we can write cos square theta plus sin square theta is 1. That means x minus 1 divided by 4 whole square plus y minus 2 divided by 6 whole square is equals to 1. Now it is of the form x minus 1 whole square by 16 plus y minus 2 whole square divided by 36 is equals to 1. So here b is greater than a, dear students. That means what is he asking? He's asking us to find the value of 5 by e square. That means eccentricity. I think e is eccentricity. Okay. So e will be under root 1 minus a square divided by b square, which is under root 1 minus 16 divided by 36. So this should be under root 20 divided by 6, which is nothing but 2 root 5 divided by 6. So e square will be 4 into 5 divided by 36. So what is he asking? 5 divided by e square should be equals to 9, right? If I rearrange, I'll get 5 divided by e square is equals to 9. That is what he's asking. That's it, dear students. Thank you for watching this video. Meet you with the next one.